And the last topic today is the setting of the trenches and the top layers. Again, we have to go to the catalog, and here you have the catalog of trenches and catalog of top layers. Inside the catalog of trenches, again, you can check and define different types of trenches. You have trenches without the step, so we call it simple trenches, and you have double trenches with the step. And you can see that you can define here basically everything. You can define the slopes for each part. You can define the angles. You can define the widths. The widths can be automatic. You can see here, these are the single ones with the defined widths. Here we have width of 1, width of 1.2, 1.5, or you can say that the width is not inside of the catalog, it's calculated. And if this is calculated, then it will be in relation to the pipe that is set for that section. It's calculated, like it says here, according to DIN European standard. So the trench width will be in relation to the pipe diameter. And also I said the catalog of upper layers. This is basically the catalog of the top of the, let's say, asphalt of the road or the soil under which our pipe is going. This is in relation to cross sections, but also to calculate the excavation volumes and different materials that has to be excavated. So here by default we have asphalt and humus. Humus, I like to change this to soil or earth or something, and you can define groups. You can define groups, and for each group you can define different layers, because when we say asphalt, it's not just one layer of asphalt. Or with soil, you can define different layers of soil with different thicknesses and with different colors. So for example, we have here, we have the asphalt first level of 5 centimeters, and I will change the color here to, I will use this darker color. And second layer of asphalt, it will be 7 centimeters, and I will change the color to this gray color. This will be visible in the cross sections and in the profiles as well. And for the soil, we have 20 centimeters of soil with the first level soil 10 centimeters and second level soil also 10 centimeters. Okay, let's now close the catalog and let's define this. So let's again go to input data for the trenches. Okay, and here you can again use the selection options. You can define different types of the trenches for different parts of the network, or you can select the entire network and set the same trench. I will use this single trench with sand bedding, where the width of the trench is calculated according to DIN standard, and the angle of the trench I will use 90. You can also, if you go to the catalog of trench, you can also turn on the phone work as well. So if you want to use phone work for the trenches with the angles of 90, you can use that as well. So that the width of the phone work, it will also go to the report, and it will also be taken into account when calculating excavation volumes. So let's click OK. I will not use phone work. Let's set this trench to the entire drawing. And again, you can see the dynamic model of Urbano. You can see how the graphical part changed. Here we have now the bedding showing here with this hatch. And also you can see that the profile table also changed. You see the trench bottom elevation and the trench bottom depth here automatically appearing calculated. Okay, let's now also set the top layers. So let's go to input data, upper layers, or the top layers. And from the catalog, first I will set everywhere 12 centimeters of asphalt. Let's click save, and let's save this. Again, if we go to our profiles, we can see now how the top layer appeared in the profile as well. Okay, let's now set additionally override. So we have to click here, override the old upper layers with new. And I will say you can go from node to node or from station to station. I will go from station to station because from the raster, I can see that here, from this point to the beginning of our network, we are not under the asphalt. We are under some, let's say, soil, okay? So I will use here soil 20 centimeters. And let's click save. Okay, and now let's check our profile. We can see that up to this point, we have one top layer with different thickness, and from this point on, we have different top layer. And now let's draw cross sections. So to draw cross sections, it's really easy, just like how we draw the profiles. You have different configurations. Inside of the configurations, you can save everything from colors to data to hatches to dimensions, everything. So let's just open the one that we will use. I will use this one in a higher scale, so 1 to 50. The cross sections will be bigger than the plan itself. So let's edit it. And here you can see that you can define all the colors, all the hatches, all the data that will go to the cross section, and also all the dimension styles. It is important to say that the AutoCAD dimension styles will be used for these dimensions. So if you want to change it, change you see ISO 25 annotative, or we have our own Urbano, which is predefined for these scales here. So I like to use the Urbano dimension style. Let's click OK. And let's now draw cross sections. Let's double click on this configuration. And now you can draw cross sections in some of characteristic points of the network, for example, in nodes where the top layer changes, or I like to use every n meter along my system. So, and also stations can go by branches or by arrays. I will go by arrays, and I will go every, let's say, 20 meter along the system. And now you have to select, you can of course select the whole system according to arrays, or you can go, for example, by arrays or from node to node. I will select just this array and this array, like this. I will define row spacing and column spacing to be 10. You can also define, just like for the profiles, how you will position them. And you see 68 cross sections will be drawn in a matter of seconds. Let's draw them and let's check them. Now you can see that all these hatches, all these dimensions, all these colors and the data. So we see which section is crossed, which diameter is this, and on which array station we are. And you can see these different top layers. So this is the soil top layer, and this is the asphalt top layer. Additionally, instead of using this automatic option in characteristic points, you can also just select some stations in plan or in profile and have the cross sections drawn there. And let's now also calculate the excavation report. Here you can have the configuration of data. Here you can set up, for example, what are the depth excavation zones, because it's not the same if we are digging the trench up to 2 meters or to 4 meters or to 6 meters, the prices will be different. So here you can define the depth excavation zones. We will have it by default from 0 to 2 meter, 2 meter to 4 meter, 4 meter to 6 meter. And you can define what data we will have here. So excavation volume, excavation zones, and so on and so on. Sand bedding volume, yes, but concrete bedding volume, we don't need it because everywhere we have the same trench. So I will delete this data. Also, we didn't set up formwork, so I will delete formwork area and formwork volume. Okay, let's click OK, and let's now run this excavation report. So double click on it. Here you can select the entire drawing, or again, some elements. Let's select the entire drawing and let's group this by arrays. Okay, let's save the report, and in a few seconds we will have this Excel report created that we can open and check it in Excel. So let's check it, and here you can see for each section, starting and ending station, total excavation volume for the entire section. Then you have excavation zones according to the depth excavation zones that we defined. You have the volumes of the top layers that we defined, excavation volume without top layer. You have sand bedding, pipe volume, all the volumes of the top layer, and trench surface area. And everything is sorted and structured by the arrays because that's how we defined it. And if we scroll to the bottom of it, we will see what is most important, and that is the total cumulative excavation and backfill layers data for the entire network.